Okay, so in the last lecture we talk about the crystal growth, crystal structure and defect uh, possible in the crystal structure. We discussed the point defect, line defect, surface defect, and volume defect. Okay, now we can start our discussion as per your syllabus about the crystal growth process. That how basically the crystal will be obtained. Our ultimate aim is to obtain a wafer. Wafer means the base onto which IC will be fabricated. And I have already said that this wafer is simply made up of single crystal silicon structure. Okay, so we want to obtain that. So if you see this slide, crystal growth process, basically in crystal growth process, we are talking about uh, forming MGS, that is metallurgical grade silicon, or EGS, that means electronic grade silicon, from the raw material like sand. Okay, so as I said, that ultimate aim is to obtain a circular disc. That means this is actually the wafer. This is what we want to obtain, and this we will obtain from this ingot. Okay, this is known as ingot, and to obtain it from this ingot we have to obtain this ingot, and this ingot is basically obtained from the raw material like sand. Okay, as I have already said you that this ingot, or basically this wafer, is made up from single crystal silicon. Okay, so single crystal silicon structure is required to be obtained first, and then only we can cut that material, that means this ingot, in circular disc shape, that means the wafer. Then the fabrication will start actually. Okay, so single crystal structure of which material is required? The material, as I said in the last lecture, is silicon. Now, the first point is that why silicon? Why do you need silicon? Why not any other material? There are a number of reasons, and you can follow my notes, okay, to understand all the points. Why silicon, why not germanium, why not any other material, etc., etc. First thing, the one thing which I should tell you right now is that silicon is abundance in nature, and if anything is found in abundance in nature, then in that case extracting that, using that, and even we are wasting a lot, there is no issue, the cost will be much less, right? It is a semiconductor, it has wide better band gap voltage, etc., etc., etc. There are various other points are also there, but one important thing is that it is abundance in nature, right? So obtaining it, using it, utilizing it is easy and cost effective. Okay, so first point is that how it is in abundance in nature. From where we basically obtain silicon? We obtain silicon from those things, those raw materials which have Si inside that. For example, SiC, silica, wood chips, right? These are the raw materials. And the important one is your sand. Sand, sand you found everywhere, right? We have number of deserts on our planet, right? And desert have sand, a lot of sand, and sand contains SiO2, and contains SiO2, from which we basically obtain Si, and contains SiC, from which we basically obtain Si. Okay, whether it is silica or it is silicon dioxide. These are the main sources from which basically we obtain our silicon. We extract our silicon. So there is one एक सिंपल सी कहावत है कि इंसान मिट्टी से आया है और मिट्टी में मिल जाएगा. The same applies here. That means mitti, that is sand. You start fabricating your chip from sand, and finally when what will happen at the end, and you will be able to utilize, a time will come when it will again, you will throw it again into the dust. Okay, so that I am only saying for the purpose that you should keep it in your mind, what is the original source, what is the basic raw material from which you obtain it, that is sand, and other raw materials like wood chips, coal, colta, etc., which contain Si inside. Okay, so the first point here is basically that what we do, you can see this first diagram and this second diagram, that basically we purify our sand. We purify our sand and we refine it, and we obtain this, which is known as quartz. Quartz is basically purified form of silicon. So we basically first purified the sand so that other materials can be removed away, which we can remove easily. Okay, and then we, after purification, we obtain quartz. We use that quartz, and from that quartz we obtain the silicon. That silicon which we obtain from this is known as purified silicon. Initially we obtain MGS, that is metallurgical grade silicon, and then we will obtain EGS, that means electronic grade silicon. From that we will obtain the silicon ingot, and from this ingot we will obtain this wafer, and then our fabrication onto the wafer will start. This is the initial phase. I hope this picture clears this, that how basically we are going to proceed. So let us proceed. Let us discuss these points. The crystal growth process, I can say, can be divided. The crystal growth process can be broadly categorized as from raw material, from basic raw material. First of all, we will obtain the, first of all, we will purify it, right? As I have shown here that we will purify it. From that, first of all, at first stage, we will obtain metallurgical grade silicon, which is near about 95 to 99% pure. Okay, from this MGS, we will obtain electronic grade silicon. This is the second stage. From that EGS, we will obtain the crystal ingot, and from that ingot we will obtain the wafer, and that wafer will then be processed to form the integrated circuit. So in this lecture we are going to discuss further that how basically we will obtain this MGS and then EGS. Then in the next lecture I will talk about the ingot formation, and in the next we will talk about the wafer preparation, silicon shaping, as per your syllabus. So let us proceed further with the next step. The first step, okay, raw material to MGS. I told you that I will discuss this first point. Let me change the color. Let me change the color of my pen. Uh, just okay. So I have told you that in this lecture we are going to discuss this portion further. Okay. In this case, first step is to obtain raw material, and then from raw material to MGS. Right. So first, let us discuss this point in the next slide. So the basic first step, sub step of the first stage is MGS from raw material, and raw material we will obtain quartzite. As I said, that quartzite is your purified form of sand. Okay, as I showed here, quartzite is your purified form of sand. Then we may have quartzite, we can use coal, we can use coke, we can use wooden chips, etc. What we will do, that we have a furnace heated at a high temperature, very high temperature. How much is that temperature? You can read it, 1600 degrees centigrade, 1780 degrees centigrade. So near more than 1500 degrees centigrade temperature is there inside the furnace. And what we are doing, we are pouring all the material like quartzite, coal, coke, wood chips, everything we are putting into the furnace. Okay, there is a submerged electrode for chemical reaction to take place. and a number of chemical reactions actually take place. A number of chemical reactions take place because different type of materials we are putting into the furnace, and they will combine together, they will react with each other. Different chemical reactions will take place. We are interested in only what? To obtain silicon, right? So we can say that basically by different reaction, basically what we will obtain: SiC, SiO, SiO2, and finally from these we will extract Si from this furnace. So overall reaction is written here. You can see here, this is SiC. This is your overall reaction, this one. Okay, so this is your SiC. Finally, we can say that overall reaction is simply SiC plus SiO2 will give us Si, that means the silicon which we need, and SiO and CO will again come. Then CO and SiO in gaseous form along with H2O will come out from the furnace, while other byproduct will again combine, and finally what will happen, we have this furnace in such a manner that when this reaction will take place and this silicon will form, we give a path here at the bottom side such that this liquid will discharge through the furnace, and when it will discharge through the furnace it will come out, and this liquid which will come out is simply silicon, and this silicon is your MGS. MGS, as I said, that metallurgical grade silicon, and metallurgical grade silicon is the name indicating that metallurgical grade. Metallurgical grade means some metal impurities are there in this silicon. So this silicon is not pure as we need. Some metallurgical impurities are there mixed with this silicon. Metallurgical impurities are there. Okay, but we have extracted the silicon from basic other form of other raw materials, right? So we have obtained the silicon, and this MGS, as I said, that is 95 to 99% pure, is basically known as metallurgical grade silicon, which we have obtained. So as we have seen in the last slide, that this is the first step which we have done. On the top left side, see here, raw material to MGS we have obtained into the furnace now. Now the next step is from MGS to EGS we have to obtain, right? So now we have to obtain from MGS to EGS. That means metallurgical grade silicon will again be purified to remove those metal impurities and to extract the electronic grade silicon, which is highest purified, which is purified form of silicon, also known as semiconductor grade silicon, EGS or SGS, the same thing. Okay, so step for obtaining SGS is simply the first step what we have discussed, that produce metallurgical grade silicon by heating silica with carbon, and other products are also there. Okay, so the reaction which we have already seen is that SiC in solid form, SiO2 in solid form inside the furnace reacted and gives us Si in liquid form. That's why that liquids are discharged through the furnace and comes out from the furnace and becomes solid now. Okay, and SiO in gaseous form and CO in gaseous form will emerge out of the furnace as the byproduct. Okay, so this was the first step. Now the second step basically we can say is the fractional distillation. You know the concept of fractional distillation, that what fractional distillation is, that boiling, cooling, and so that some impurities will move away, right? So we use basically that concept further after obtaining the metallurgical grade silicon to extract the impurities from this silicon. Okay, so the next step, the second step, you can read it here: purify metallurgical grade silicon through a chemical reaction to produce a silicon bearing gas SiHCl3. Okay, so first we reacted with a gas at a high temperature, and then we will slow down the temperature. Okay, for the purpose of fractional distillation, and will heat will be away with some impurities taken out. Okay, so Si in solid form, after coming out from the furnace from liquid state, it becomes solid. Okay, when it will become solid, it will become solid, the first thing what we will do is that we pulverize it. We pulverize it means it is a solid form and it is accumulated at one place. So we pulverize it and we obtain something like stone form, right? In some raw form, the pieces of metallurgical grade silicon. Then we again heat it. We combine it, this solid with the HCl gas. Okay, we combine this solid with HCl gas and we obtain basically another gas. We convert this silicon again into this SiHCl3, that means trichlorosilane. We obtain the gas of trichlorosilane from the silicon solid. Okay, and S2 gas will emerge out, heat will produce. Now see the third step. Now see the third step. SiHCl3 and hydrogen react in a process called Siemens to obtain pure semiconductor grade silicon. Now see this process. 2SiHCl3 gas combined with hydrogen gas gives us 2Si solid plus HCl gas. Now have a look on these two reactions. Are not these the reversible reaction? First we are combining Si with HCl giving SiHCl3. S2 is emerging out. Now we are combining SiHCl3 with S2, right? And Si is emerging out with HCl gas. So what basically we are doing? Here to there and there to here. This is what fractional distillation I told you, right? So this is what we are doing in the next step. And the third step which we are doing, that trichlorosilane is combining with the gas of hydrogen giving Si in solid form again, is basically done in a chamber, and this process is known as chemical vapor deposition process. Okay, and basically finally we obtain this 2Si as written here. Finally we obtain this silicon which is highest, not I should say highest, but which is purest form of silicon. Okay, even this SGS which we obtain, okay, is purest form of silicon. We can say that it is 99.999% purified form of silicon, that is known as electronic grade silicon. Okay, so now see that how basically we obtain EGS in the third step using CVD, chemical vapor deposition process. Let us see this third step. The third step, the CVD process, is shown here. Basically, you can see that I am just redrawing this diagram here to so that you can visualize. Basically, we have a quartz tube. We have a tube like structure, and inside the tube like structure we fixed a rod. This is a rod which I am just drawing. This is a rod, and this rod is basically made up of polysilicon. This is the polysilicon structure which we are already having, and we are putting a rod of polysilicon inside this uh, chamber. Okay, so coming back here again, see this is the reaction chamber, and a bridge is formed. This bridge is formed with the help of this polysilicon rod. This is your polysilicon rod, polycrystalline silicon rod, and this is made up of quartz. This chamber, okay, and holder is made up of graphite so that it can sustain the high temperature. Graphite holders are there to fix these rod here. Okay, so this rod is fixed here. Now what happens that we have said the reaction take place is SiHCl3 trichlorosilane gas will combine with what? Hydrogen gas, and when they will combine they will give Si in solid form and HCl gas will emerge out, right? This is what we have already discussed, right? So how basically this will happen, that see here SiHCl3 plus H2, these gases will be passed here in this chamber. Then the reaction will take place and the silicon in solid form will appear and will be deposited. When this silicon in solid form will form by this reaction taking place, what will happen, that this silicon which will come in, I was just changing the color of pen, and Okay, so what will happen that when these gases will come inside, okay, what will happen, the silicon material will come in solid form, will be formed from the by combining these two gases, and that solid will be deposited over this polysilicon rod. So that will be deposited over this polysilicon rod, and automatically it will take the shape and the structure of this polysilicon which we have already there. So the material will continuously deposited here, and the residual gases will emerge out from the furnace. Okay, that you can see here that the residual gases will emerge out from the chamber, and when the reaction will take place, the material, the silicon solid in solid form will be deposited over this polycrystalline rod, and hence will take the shape of this. So finally, in this manner we will obtain the polycrystalline silicon structure in this chamber using the chemical vapor deposition process. Okay, so we will obtain finally a rod of silicon, a thick rod of silicon. Okay, and then we can again pulverize it or whatever we want to do. We can just change the shape and we can have the material which is known as electronic grade silicon, which is basically polycrystalline silicon structure and purified form of silicon, that means 99.99% pure, because other residual gases have come out from the cabin, right? So this process basically other impurities, other metallurgical impurities which were there in metallurgical grade silicon will move away, will be extracted, and purified of form of silicon will be deposited onto the polycrystalline silicon rod. It will be deposited on this polycrystalline silicon rod, and other materials will move away, right? In this manner we will obtain this EGS. So these three steps which we have just seen, I would like to say that this is the first step. Sorry, so this is the first step. Okay, and in the second step I would like to say that in the second step what we will do, let me first write that the first step is of raw material to EGS formation, which you have just studied. Then the second step is EGS to ingot formation. Ingot formation means now from polycrystalline structure of silicon which we have obtained, we will obtain the single crystal silicon structure. This is your second step, and then the third step will be from ingot, that means the single crystal structure, that means the single crystal structure, we will obtain again the single crystal, but from ingot to wafer, that means the circular disc on which we can fabricate our chip. Okay, so we have just discussed the first step. The second step and third steps will be discussed later in the next lectures. Okay, right now at last I want to tell you about another process known as pyrolysis of silicon. In the current process you have seen that initially in the first sub step of the first step we have seen that we have obtained the metallurgical grade silicon. Then from metallurgical grade silicon using fractional distillation and sub step 2 and 3 we are obtaining silicon in purified form, that is EGS, using by reacting it with HCl to form trichlorosilane, and by reacting trichlorosilane gas with hydrogen to produce the silicon. So these two steps which we have just seen, that means basically we combine SiHCl3 with H2 to give our silicon in solid form. Instead of this, instead of using this trichlorosilane, we can use silane gas, and that process is known as pyrolysis of silane. What is that process? That silane gas automatically decomposes at high temperature. I am repeating my words, that silane gas SiH4 automatically decomposes at high temperature into silicon, and hydrogen gas emerges out. So this is comparatively a simple process known as pyrolysis of silane. Okay, but it has some drawbacks also. and we can compare that which process is better, whether trichlorosilane is better or silane gas is better. That you will be able to understand later on during this course. I will tell you at the right moment. Okay, for the present moment, we can only say that we can obtain EGS from MGS. I am writing here that we can obtain EGS from MGS either by using silane gas, trichlorosilane gas, or we can obtain it by using silane gas. These are the two ways to obtain. Whatever the way we use, that doesn't matter. We will finally obtain the EGS, and the EGS means polycrystalline. EGS means polycrystalline silicon. We have obtained the silicon crystal structure in multicrystalline, that is polycrystalline form, and this polycrystalline silicon is 99.99999% pure. Okay, so up to this point we have discussed right now. In the next lecture, we will discuss the second step. The second step, that means EGS2 ingot formation. This one. We have obtained this purified silicon EGS, and then we are going to obtain this silicon ingot in the next step that we will discuss in the next lecture.